Hello. Hello. All right. Okay, so I have a green light to start. So yeah, just first of all, before presenting myself or introducing myself, just want to say thanks to everyone who organized this conference, who gave me the opportunity to be here. Plus, big thanks to all of you for coming to this talk. So another thing is like have a special guest today. So my sister is here. So just would ask you for a big applause because of her. Actually, I wanted to do this because then she can tell mom that I'm doing something useful. Because you never know. I mean, if you ask my mom what I'm doing, she might say, yeah, he does something with computers. You know, that's how it goes. So today, I'll be talking about how to work with big mobile code bases. This comes from experiences at SoundCloud. I'll be introducing myself a little bit. I'm Fernando Cejas. I'm originally from Argentina. I'm living in Berlin. I'm working at SoundCloud, or I used to work at it, so I'm going to be telling you some true facts. Others are not that true anymore. I'm a curious learner, and again, because I quit SoundCloud a couple of weeks ago after 3 years, but still I wanted to give this talk one more time because I think it's very useful. And I caught up with my team last week and got some updates on how we are working and so forth. So I'm now a SoundCloud alumni, so that means the next SoundClouder. The good thing about this talk is actually that I have given it a few times. So the feedback I got out of it is like, sometimes it's very general. Other people really like it because I'm basically telling people how you can work with big mobile code bases. It's not pretty straightforward. As it sounds sometimes, we are developers and we write code and we say like, I'm going to develop this big application. And then it turns out that there's a lot of moving parts. It's not the same when you're working on your pet project. And that's why, well, I have a blog, that I try to keep up to date. You can visit it. I try to share my experiences as I'm doing here. I have to say that I'm not a good developer. I'm just like here to share all the disasters I made during my professional life and all the lessons learned I got out of that. So basically this talk starts with a small story, a little one. And it's the story of SoundCloud. If you think about SoundCloud as a platform, we have around 200 million users. So that brings up a lot of challenges. But how all this really started? So basically, let's say then you have a pet project. I think many of us here have our pet projects, right? We're working on some cool stuff on our apps. We want to succeed, actually, right? You're a happy developer, basically. And let me ask you some questions here. Then, how many of you are Android developers here? All right. iOS? Wow, that's surprising. I'll be telling some stuff around iOS too. Basically, because I used to be part of core engineering at SoundCloud. So that means our team was called Core Clients. And we basically did all the infrastructure stuff and things that are very software engineering related to both clients. So feel free to ask questions around iOS as well. Even though I consider myself more an Android dev. I don't have like really deep knowledge on the iOS platform. But as you will see, in the end, we are facing the same challenges with different implementations, I would say. But in the end, that's part of the shared knowledge thing. What else? So what happens when you have your your project, your small project, you're the only maintainer of that, which means you make the technical decisions, right? I mean, probably you're not reviewing your code. You just start moving forward, writing code, and so forth. Then you don't have many tests. And this brings up another question, which is how many of you write tests? OK, good. I see. Too bad for those that don't. And I will give the reasons why. That's very important. So getting back to this pet project, this is what I call a one-man development process model. So again, you're by yourself. You don't need code reviews, probably. You're not dealing with code consistency. You just want to succeed. You just want to explore. You just want to learn new stuff, and so forth. And but what happens? At some point, you really succeed. And this is what happened with SoundCloud. There was a one-man development process model. There was this guy in the US who developed a SoundCloud client, Android client. And at some point, he got very successful. Millions of users started using his app. And that brings up a lot of downsides as well. I mean, it's nice because the project starts to grow a lot. Of course, you need more features because you have more users. And it really, I mean, you're really enjoying that moment when people say, give you some feedback and say, all right, you should definitely add this or that and so forth. And you're really, really happy for that success. And so you start writing code and say, all right, this is really working. But what happens? What is the first problem here? Success. And this is actually, these are real numbers from our both Android and iOS apps. So as you can see, these are the numbers of installs we currently have. And that's a problem as well. Because when you screw it up at a very big scale. And that's why you need to take care more about code quality and so forth. And I will tell you a little story. It's a personal story. When I really, really screw it up, I don't even want to think about how much money I made the company lose. But basically, it was my first week at SoundCloud, and shit, God, well, I'm no longer a SoundClouder. So, but basically, I took care of the release, the next release. Back in the days, we had a very manual release process, and I will tell you how we evolved towards another direction, a better one, with a more mature continuous integration pipeline and so forth. But yeah, getting back to the topic. So I had to take care of the release, and I remember we had around 100 million users on Android, and before releasing, I had to switch from the API we were using for serving all those Android users from the dev version to the production version. And so I forgot to do that. And we had 3 machines in the office which were serving 100 million users. 3 old machines that we used for development, right? And at some point, I just went home, just really happy that I could, achieve that goal. And yeah, I went running, I remember, and I was trying to use the app, the new version, my version, the first version I would ship. And I couldn't play a song. It's just oh, this is not working. And 5 minutes later, the CEO of the company just called me and said, I was told that you were the release captain for this. Is that you? Just hung up. So I said, yes. So I don't know if you noticed that, but the app is not working. Yes, I did notice that. So so I don't know. I don't want to give many numbers, but we had that app live for a few hours, that made a lot of that made the company to lose a lot of money. The good thing about that is like we solved the problem by just increasing the number of instances of our development version of the API. So that meant, I mean, we were still using the development version, which was not that bad because there was some feature parity. So it was not bad. But the good thing is was like, what happens if you screw it up within a small app? It's not, you're not screwing it that much, you know? And the good thing about all this is like there was no finger pointing. The team said, all right, it was you. No. So basically the team said, all right, so we fixed the problem. We did a lot of retrospective to make sure that we are not committing the same mistake again. But that's a little story I wanted to tell, that we all make mistakes and we learn out of that. And especially when it comes to big mobile code base. We're not perfect in the end. So what happens when you're successful? Of course, your code base grows. You have no test, probably. And there is inconsistency across the code because you're shipping features pretty fast, and you're just probably copying and pasting code from one place to the other. And that's pretty normal, right? But at some point, actually, it's like when you feel really annoyed about that. And imagine in our case, we have around like 20 Android developers and 25 iOS developers committing code every day to our mobile clients' code bases. So that means a lot of code, every single day. So that's when we run into an unsustainable situation, right? Why? We need more features. More contributors are jumping on board. At some point, there were some layoffs at SoundCloud, but at some point we were hiring people, like 3 or 4 people every 2 weeks. I would say like it was crazy. And how do you onboard all these people? How do you make sure that all these people are feeling comfortable with the code base? It's very difficult. And it's something that you don't see in small apps, or maybe you see it, but not in such a big way. And time to market. There's always pressure from business, because sometimes we say, I think, from my perspective, it's like the more senior we become, the less code we write. Especially if you're working for a big company, it's just like, you just make sure that you're putting all the pieces in place, you take more initiatives. At least that's in my experience. I write code, of course, but not as much as I used to do. And that's why you need to take care of all these little things, which are not that little in the end. And you have a lot of complexity. I'm going to give you some numbers here of the number of lines of code that we currently have. But then, again, what are the questions that need an answer then? Because there's pressure from business, how can we add a new functionality pretty fast? Is our code base prepared to scale? And that means if we are onboarding someone, if we are adding new functionality, are we just increasing our technical depth, for example? Many questions should be answered. Is it hard to maintain? Of course. One of the things I usually ask is like how much technical debt we generate every day. We cannot predict the future. I mean, I always say like today I'm writing tomorrow's legacy code. That's it, it's as simple as that. So how many of you have a process for technical debt killing? Okay, I'm very curious how you struggle with technical debt. I'm going to give you some hints on how we do it, but I'm pretty curious because then this is a snowball effect, right? At some point, I mean, the snowball becomes more and more big or bigger. And what else? And how we can keep our code base health and sane. And again, the onboarding thing is very important. But I'm going to introduce a bunch of facts, things that I think are important when it comes to working with a big mobile code base. So the number one is like, if your code is hard to work with, just change it. Sometimes we are afraid of changing things, or we don't want to touch things, right? Because we don't want to dive deeper into something that hasn't been touched for a long time. But I would definitely say there's ways to do that. You can always pick a little part of your app and refactor it and so forth. And at SoundCloud, we many times talk about how we scale our microservices infrastructure. I'm not going to talk about our backend services. Still, I'm going to mention it, and I'm going to show you the general architecture of our ecosystem. But we talk about that so many times, how we pass from a monolith, from a Ruby on Rails app to hundreds of microservices. So that means evolution. You have to evolve your code if you want to grow up. And this is not true. This is not a SoundCloud app repo demo. It's more, I just want to show you a tool, a pretty cool one. OK, so this is basically, it's a pretty cool tool, actually. It's called GURS. How many of you know this tool? All right, nice. So this tool basically shows you in a very cool way, in a very graphical way. You can set it up. There's tons of commands that you can use. But it basically gives you a hint on what are the most touched files and so forth. And there is a really interesting book if you want to dive into your code, because by having all these tools, you can get a lot of data from your code base. For example, what are the most touched files? What are the areas where most people are contributing to? And you can get a lot of conclusions there. Like, for example, if 10 people are touching the same file every day, so that's probably telling you something, that you need to refactor that code, that you need to extract some stuff from there. Or maybe that your class is too big, for example. And a tip that I have for you is, like, if you have time, we never have time, but if you have it, just read a book which is called Code as a Crime Scene. So it basically tells you about all this, about how you can statically analyze your code base and come up with conclusions around it. Like, for example, what to refactor, when to refactor, and so forth. And it will show you tools like this one. This is a really cool way. I mean, it's a very graphical way. This is a WordPress repo, basically. I just grab a repo and just wanted to see the evolution of it. You can see how many people now are contributing and moving around the code base here, right? So with that being said, I'm going to get back to the presentation. So I lied. It's not a SoundCloud app repo because I have no longer access to it. But it was pretty similar. So what can we do then to support all these big mobile code bases? We need to tackle our code bases, of course, but there's a lot of moving parts around that. What about team organization? Because we made so many mistakes. We restructured our teams, I don't know, I would say like 3 times in the last 2 years. So to tackle these problems. Because we first started, as a feature teams, then it didn't work. Then we did something with squads, as Spotify was doing. It didn't work out. And then I'm going to show you how we're working today. Working culture, that's very important as well. And that means pair programming. That means being involved in the hiring process, flexibility, time flexibility. We have a lot of support for working on our personal projects, for example. As soon as you get the shit done, people might not care about how you invest or how you manage your own time. As soon as we connect to each other, and that's part of the culture. And I found that really, really interesting and very useful for working. Because you don't feel like, in my case, I have to say that I almost changed to German. I had a lot of flexibility. And and then I could go to the office at noontime and then work, I don't know, 3-4 hours. As soon as I get everything done, it's not a problem then. But that's why it's important, and it's important that everyone fits within the same culture. Everyone, at least we care about like people being super friendly and useful and very open to receive feedback. So as you can see, there's all these moving parts that need to fit all together, and we need to assemble this puzzle in order to succeed with big code bases. And so, with that being said, what are the worst enemies of these code bases, these big ones? First one, size. The bigger your code base is, then the more problems you might run into. Complexity. This is code. I don't want you to pay attention to this piece of code, but basically, this is it's a method to find a node in a red-black tree. So if you start reading this, this is a very complex code. Most of the time, it will take some time to figure out what's going on there. That's why complexity must be hidden. You have to encapsulate complexity, always. Just wrap it inside a method or another method or an object or whatever. Flaky tests. So that's another problem you might run into, or at least we run into. Flakiness, everyone knows the concept of flakiness here? So a flaky test is a test that fails for specific, not reasons related to your logic. For example, I would say when you have end-to-end tests or acceptance tests, let's say you're testing your app in a UI way, a test might fail for many reasons, right? It might fail because of some logic. It might fail because of network conditions, because we are dealing with mobile devices. When we are running those tests, maybe your network is not working, and you don't know why, and you get a failure. And you have to spend time on that. Or maybe race conditions, or whatever reason. So especially when it comes to UI tests, most of the time they are flaky by nature. Because of all these conditions I mentioned. A unit test is something completely different, could fail for other reasons as well, but UI tests tend to fail a lot. So these are the list of tests that we see that are failing because of flakiness. So we basically develop a platform inside to detect which are the flaky tests. And every single day when we go to Slack, we see which are the tests that failed the previous day. So that's one of the enemies. We spend a lot of time trying to figure out flakiness, and it's something that you might run into. And you need acceptance tests. Anti-patterns. That's another enemy of our code base. I have to say, in this case, I just searched for an async task in our code base. This is an Android related for the iOS people. This is an Android related class. So it basically will execute some task in a separate thread, but everything is super coupled here. And I'm not going to talk about how bad it is to use async tasks nowadays. But for me, that's a legacy code. Because, there is a lot of coupling here. You're coupling UI with domain logic and so forth, and threading and so forth. So, but the main point of this is the anti-patterns. We are really having problems with a lava anti-pattern. I don't know if you're familiar with the concept of lava anti-pattern. Do you know what that means? No? So, all these things have these names, but it's basically when in your code base you have many ways of doing the same thing. So I think that happens a lot. Imagine you have something new jumping on board in your team, and this person just is new, and he or she asks, how do I perform a network call? And they say, all right, there's two ways, or in this feature it's being done this way, but in this one it's being done this way. So which is the good one? And that happens a lot. And that's about code consistency, right? We need to solve these problems with keeping code consistent. I mean, there should be a feature that we use as a reference for developing the rest of the features, because then you're familiar with the piece of code, right? I mean, you will be jumping around different features and you will find that very familiar, because everything follows up the same structure. Of course, technical depth. This is something I grabbed from our app as well. We are all running into technical depth. There's no perfect code base. And this is basically a class that we were using for hitting our public API. So don't pay attention to the details. I just wanted to flag that we are using a singleton here, and we call it as a get instance. Singletons are not bad when you don't use it for keeping global state. When you want to create classes that only contains one instance, it's totally fine to use, and that's why we're using it. There are some objects that are very expensive to create, so that's why we use singletons. But in this case, there was this get instance, and for instance, we are still using a dependency injector, so that should be managed by our dependency injector. At least on Android, we have something that facilitates our process. And so the thing is, we need to find solutions to all these problems. Fact number 2, architecture matters. I talked about architecture a few times. I wrote a few times as well. I'm not a big defender of like specific architecture, even though that I'm using something that works for me. I think you should definitely use what works for you. There's so many options out there. You can use many different architectures. I want to mention a few of them, but you need always a new architecture when new requirements comes in. When you want to scale, it's the same as I mentioned before with Ruby on Rails. It didn't work out. I mean, I think we were serving millions of users with a Ruby on Rails server, and it didn't work out. At some point, I mean, we needed to refactor that code. We needed to re-architecture it. And the same happened with our Android and iOS app. Actually, the iOS team, they are working on modularizing the app, because there's so many developers jumping in and everyone is touching the same part of the code as I mentioned before. And they are working on that. So basically, they extract one feature that they use as a reference, as an example. Sorry. And they are working on that. And on the Android side, we are still considering that, but we are not there yet, because our architecture is really working well. So the thing is, pick an architecture and just stick to it. It doesn't matter whether that is an onion layers, a clean architecture, ports and adapters, model view presenter in a very pure way, custom combination, and we are using that at SoundCloud. When I started writing about like clean architecture, people ask me, "Oh, how do you use it?" I'm not using it. I just wrote about it. I'm just using a custom combination, because you cannot solve all the problems with a single architecture. You have to adapt it. Of course, it's based on that, but it's not strictly following all the principles. And your own, and that's what we did as well. We have something we call Spoker. Don't ask me why. Someone just came up with this kind of cool name. And it's based, of course, clean architecture with use cases, and if you're familiar with that concept. We can deviate the topic, and I would definitely love to catch up with anyone interested in that topic. But the thing here is like use your own architecture, stick to it, and keep your code consistency. And the benefits, of course, is rapid development. You might just grab a feature and it's not about copying and pasting code, but it's still like following kind of some principles that you decided to use across your code base. Your code is going to scale pretty well because it's consistent. And you just probably, the idea behind an architecture is just to follow up certain rules, right? And we created a framework around that that we extend, so it scales pretty well. And this is basically like a small picture of our SoundCloud ecosystem. Just gonna go quickly here. So basically we have our clients, the web clients, the Android and iOS clients. Then we have 2 BFFs. This is a pattern, a very well-known pattern, which is called backend for frontend. So basically we have 2 APIs, one for mobile and another for web. So that means, of course, it makes sense because we share most of the data between iOS and Android because there is a feature parity. So there's no need to create separated APIs for both platforms. For web, it's completely something different. It's another client. And this BFF's pattern is basically, let's say, a layer on top of our microservice architecture. So we have, like, as I said, like 140 microservices. And all of them, I mean, they're different programming language, because that's a good thing about the microservices, because it's an isolated piece of code that works and communicates with other microservices. So you can basically pick different programming languages according to your needs. But most of the time we are using Scala. We are using, just out of curiosity, we are using a framework from Twitter, which is called Finagle. And Finagle is basically a reactive framework. It gives you a lot of things for free. So basically, each microservices, to generate the output for the APIs data for our mobile clients, we are basically composing what is coming from each specific microservices. We are composing in a very reactive way, and then by using futures. And then we process the data and return it to the clients. And we are doing the same with our API Web BFF. Other thing, like, this is a piece of code of our Android app. I'm not want you to get into the details, basically. But it's just like saying, this is an activity for us. It's pretty tiny. I mean, most of the time you run into these God classes with tons of lines of code. They're really hard to maintain. So basically, what I wanted to show is like how we evolve our code. I mean, this is an activity. It has like around, I don't know, 60 or 70 lines of code. This is a fragment as well. So we are basically running away from the framework. And iOS is doing the same thing. It says everything is encapsulated outside the framework. We don't want to deal with the framework. We just want to we just want to make sure that we are able to test our classes. And you know how many problems the frameworks bring up in terms of testing when you depend too much on the framework. Fact number 3, there is, again, evolution in your code. You need to constantly refactor it. Be a good Boy Scout, explore new technologies, and of course try out new things, new approaches. I think most of the time, again, we are a bit afraid of trying out new things or exploring new technologies. We bet on RxJava back in 2012 when RxJava was really new. And I think it gave us a lot of good things, and we are really happy with it. Now we are migrating to RxJava 2. You can imagine that you married to RxJava when you use it in your code base. And we are still refactoring. We are doing it in baby steps, of course. I can give you more details if you're interested in that. But that's what I wanted to say. We are constantly evolving our code about using refactoring. And always, if you do it, just do it in a baby steps, like little by little. Just wanted to point just a piece of code that we had in our code base. So this is basically a processor that we were using. And so basically, this is part of the domain layer. So what happens here? If you're familiar with the solid principles, this is basically breaking the open-close principle, which stands for every time that I need to add a new processor, I will have to modify my domain logic. And my domain logic is what is solving my problem. right? So I don't want to do this. I don't want to touch that piece of code every time I add a new processor. So basically, just, when you run into this situation, you find this kind of piece of code. Just refactor it. Be a good Boy Scout. I mean, your colleagues will appreciate that. And so basically, yeah, what we did is just as easy as creating interfaces and extracting the key processor into a map outside your domain logic. So every time you need a new processor, you just add it to the map, and that's it. And you only keep this piece of code in your domain logic, which is basically, you're getting rid of all these switch cases and so forth, which are pretty bad. Again, testing. I'm not going to touch any piece of code that don't have or doesn't have tests. That's for me. Because what's the main purpose of tests? The main purpose is to make sure that your code works as expected. So if you don't have tests, what happens? If I touch something, I don't know if I'm breaking part of your code. So that's why how we do it. We have a very mature, again, continuous integration pipeline. We have developed a few tools. I know that many companies which are not that big cannot do that because it takes time, it takes a lot of effort, and it takes a lot of resources and money as well. But again, even though that, we are still struggling with technical debt. We have technical debt, anti-patterns, legacy code. And how we do this? For me, technical debt means code without tests. That's technical debt. Abandoned code as well, code that hasn't been touched for a long time, is technical debt. I'm pretty sure that everyone here has this piece of code in your code base that no one wants to touch, right? And my advice here is just like, struggle with it. Don't let technical debt beat you. How you do that? How we do it? We have something called a technical debt radar. Of course, we use a static analysis tool, but I found this technical debt radar pretty useful. And this is our reality, basically. What this means, basically, here is that we have two axes, X and Y, right? And so this means development time, and this is how much pain that causes. And so we have meetings when we say, all right, so let's write some post-its and see what are the part of the code that are really painful. And we just locate it in this graph. Here, basically, we're having problems with our dependency injection. We're having problems with our data layer. It's not scaling. Our queries to our database, our internal databases are pretty slow. So what does all this means? So basically, how would you get conclusions out of this? Here we're saying, all right, dependency injection is something that takes a lot of development time. Because in our case, I mean, we have this huge graph of dependencies that we are loading at our application startup. And how do we refactor that? It takes a lot of time. And it's very painful because it affects the performance. So you would say, all right, maybe we don't need to tackle this problem. Not yet, because it's taking a lot of dev time and it's causing a lot of pain. But what happens if you have something that takes less development time and causes a lot of pain? You are adding a lot of value. And maybe it's time to prioritize logging in our case, because it's very legacy, but it's not pretty hard to resolve. So that brings me to the fact number 6. Favor always code readability over performance, unless performance is critical for your business. I know that many people might be against it, but I would say just solve the problem and then you tackle performance. Because always what we tend to do with performance, like we think that something is not performing well. But the first rule of performance is to measure, right? I mean, we never measure and we think, all right, so I'm going to improve this piece of code. But we don't have measurements. At SoundCloud, we developed a real-time monitoring system for our mobile apps. And so we're keeping track on performance from startup time. And you have no idea how much that changes between devices, between environments, between countries because of 3G networks and so forth. So sometimes when we think, all right, performance, yeah, you need to address it if it's critical, but please favor code readability. Because for me, it's like, there is like this saying from Martin Fowler, which states something like this. It says, yeah, write code as the person who is gonna read it is a serial killer. So basically, you want to make them happy, right? Because that's what usually happens. Like, you just see some piece of code and say like, oh, who the hell wrote this? Maybe it was you, right? I mean, it's happened to me a few times. But always encapsulate complexity and monitor it. So that's how we are working currently at SoundCloud. I mean, and this is not a job coming from 2 months ago. I mean, it's constantly evolving, and we have to spend years to reach to this level. And again, how do we share logic between between apps? We have Android app, we have iOS app, we have actually 2 Android apps. So we have something we call AndroidKit, which is a very original name. And it's basically, we have 2 Android apps, so we share common logic, and we encapsulate it into this library. We have something called Skippy that we share across both platforms. Like, so both Android and iOS are using our player, developed under C++. So, so basically, we are sharing that piece of code. Lightcycle, which is another Android library, you can check it out on GitHub. It's open source, but basically, it's going to spit out all the activities and fragments, lifecycle events to your classes. So basically, you can run away from the framework. I can give you more details later, but it's very well documented if you want to check it out. Propeller is our attempt to query our database. It's a layer on top of SQLite, and basically we created it in a very reactive way using RxJava. And always automate all things. We're no longer having any manual process. Again, it took us 2 years of effort to just have this mature continuous integration pipeline. And we have continuous building, we have continuous integration, and we have continuous deployment. So we're not even testing our app manually before shipping it. Everything happens at a CI level. And there's a bunch of lessons so far to summarize and to just keep you up to date. So always wrap third-party libraries. That's a lesson learned to me. You cannot, of course, wrap RxJava. But for example, when you're using a network connection library, just wrap it or encapsulate it in your own classes. So it's going to be easier then to just change it. Do not overthink too much. Sometimes as engineers, we tend to reinvent the wheel. And we want to create the next generation reactive library. And probably there's something out there that you can reuse or contribute. Early optimization is bad. Again, for me, that's very important. Don't add complexity to your code because you think it's going to perform better. And trial error does not always work. Sometimes you see a true flag somewhere and say, oh, maybe if I change this to false, it's going to work. No, well, maybe, but yeah, it's very likely that it's not going to work. And divide and conquer. Always like sometimes when we need to solve a big problem, we just start like, oh my God, it's going to be super tough and so forth. Just split that up or break it down into smaller pieces and start from small pieces to bigger ones. And of course, prevention is better than cure. Don't start creating God classes right away, and then if you can avoid that from the beginning, then it's going to be way better. And another fact, number 10, how do we work as a team at SoundCloud? We have a platform tech lead, so it's a person who have the big picture of our code base in both iOS and Android. So he basically knows, or she, in the case of iOS, knows the big picture of the needs of each platform code base, which are the most painful areas, and so forth. We have a core team. This used to be my team, actually. And we basically address all the infrastructure problems related to our mobile clients. Infrastructure means all the problems that are, I don't know, they're across the code base, not a specific feature. For example, I would say dependency injection is our responsibility. Data layer, things that are used across the entire code base, that's our responsibility to solve. We have feature teams, of course, people who are working in feature development at the UI level more. We have a testing engineering team. I know that many companies cannot have all these teams, right? But that's the purpose of this talk. Whenever you start growing up, you will need all these kind of things. I mean, otherwise it's going to be very challenging and tough to really succeed within a big mobile code base. And this is basically the structure. It's a picture of how we organize our teams. These are our feature teams are split into two. There's iOS developers and Android developers in both teams. So we still have collective meetings, which means we still meet up with the entire platform teams. So both iOS share knowledge, of course. We participate in both meetings. For example, architectural meetings, we try to follow the same patterns, but we still have problems related to Android and iOS. And we have a core engineering, test engineering, the tech leads, which basically are connecting with collective platforms and core engineering. So again, the working culture. We do a lot of pair programming. I'm not going to talk about the benefits of that, but like 80% of our time we are pairing. And I know sometimes it's tough to demonstrate to business the value of pair programming, because business might say, all right, so I'm getting the same amount of code for the double amount of money, right? Because two people are in front of a computer working on one thing. It's not that true. We can discuss that later. We use a Git branching model. This is very important because we don't accept PRs bigger than 500 lines of code, because otherwise no one is going to review it. I'm pretty sure that you run into this situation where like you get a 2,000 lines of code PR and everything is fine, no comments at all. And then you get one of 10 lines of code and there's like, I don't know, 100 comments there. Like everyone found something to say. So I think 500 lines of code is a very well-balanced number in order to review your code. Of course, as I said, we have meetings in both platforms to share knowledge. We try to be agile. We don't stick to any agile methodology, but each team is free to pick one. There's no restrictions on that. Again, the collective sync meeting between platforms. And we have different process for onboarding new people. So when someone new comes on board, we pair most of the time. So if you were to join SoundCloud, you might be pairing for the next 2 months, for example, with different people from different features, teams, and so forth. We have process. We are really involved into the hiring process. I think you have to be involved, and it's not like you show up at the office and here's the new guy and you barely know about this person. So we do that in a very anonymous way, but we participate. So I don't know who's going to be doing the pair programming session, but if you were to join like some time ago, you would pair with me, for example. It's pretty easy. We have something we call the sheriff, who is like someone who takes care of tests, basically. So that role changes a lot. Every 2 weeks, we change the sheriff to get familiar with our testing battery. And we use a release train model. Are you familiar with the release train? Yeah? So release train model is basically just a quick overview. is basically we're releasing every 2 weeks, and we ship all the features that are ready to be shipped every 2 weeks. If something is not ready, we're not shipping it, and you have to wait another 2 weeks in order to catch the train. And you have to be strict with that. It's not like, all right, maybe we can delay the train a little bit. Don't do that, because then it gets messy. And of course, we do dog fooding, which means we eat our own food through an alpha version of the app. And we have a beta community of 4,000 people who are providing us feedback and so forth. And yeah, and that's pretty much our process. So in order to recap, just quickly, if your code is hard to work with, just change it. Always stick to an architecture. It's going to facilitate your code consistency, especially. Evolve your code base through continuous improvement. All the time, just refactoring. Don't let that piece of code be there when you see it. Have tests, write tests. That's what I said. Tests are going to make sure that your app works as expected. You will run into less number of bugs. Do not let technical debt beat you. Just tackle it. You have. I definitely encourage you to try a technical debt rather. It's pretty useful, and when you start using it and learning from it, you will also get a lot of knowledge on the painful areas of your code base. Favor readability, again. And always share logic. I mean, don't write twice or 3 times your code. And if you are able to share that knowledge or that code between platforms or between different apps, just go for it. Automate. No manual process involved, if it's possible, because otherwise it will happen what happened to me, that I forgot to change this API endpoint and so forth. You need communication all the time, especially if you're 25 developers. We're 50 people between iOS and Android. And how do you communicate? So you need to work as a team. And since, as a conclusion, and just to wrap it up, if you're using object-oriented programming, use solid principles. That's going to help you a lot. And the most important part for me is like make it fun. I mean, it's proven that everything that is fun, there is a strong relationship with getting the things done. So if you're having fun, so you're going to finish up your work. And if you're not having fun, I always say, like, we have in a very privileged position in IT these days. So maybe you're not in the right place. And I think that's pretty much I had to offer. I just wanted to give you an overview of how we work. And the idea behind all this is like I'm going to be around, and we can address all these problems in a very particular way with all of you. I encourage you to come to show up and ask me questions, or we can even pair, or I can help you out with anything. I'll be more than happy to help out. And I think we have time for questions, right? Yes, we have. Please. And thank you first. Yeah.